Hi, I'm Ross Adams, and I'm an application engineer at Markforged. My previous position was a tool designer at an aerospace and defense company. We're doing a video today to do an application spotlight on a particular application that has a strong niche inside the aerospace and defense industry. This particular application is a drill plate. Drill plates go by a lot of different names throughout the industry. They could be drill guides, drill jigs, drill templates. What they're used for is to repeatedly drill a hole pattern onto a component. Just like any other type of tool, it makes a cumbersome operation much simpler. So where are drill plates used? Well, they're used on operations that the drill needs to be done by hand or on the bench. So instances where the cart is too large for a CNC machine, or perhaps it's part of an assembly that you can't bring to the machine. Or it could be a composite layup where inherently through the manufacturing process, you need to do post-processing to achieve a hole pattern that mounts into the component. What are drill plates used for? Well, they're used to drill the locations of holes for things such as socket head cap screws, high locks, rivets, dowel pins, any type of fastener or locator that goes onto an aircraft. And these fasteners are used to assemble components such as brackets, clips, hydraulic lines, ductwork, fairings, door handles, all sorts of different components that go onto aircrafts. Now, why would you 3D print a drill plate versus machine one? Well, a lot of the times it makes sense to machine drill plates. These are instances where the geometry is going to be orthogonal and uniform hole patterns, so this is much simpler for a machining operation. But in aerospace, oftentimes we're dealing with contoured components to reduce aerodynamic drag. And this is going to be much more complex for machining operations. So Markforged offers a unique solution for 3D printing where we have composite and metal 3D printers. And you can really leverage these to increase your velocity of the tool design. Continuous carbon fiber reinforcement really makes the tool operation much more durable because we know that when these tools get used down on the shop floor, they're not going to be gentle with them. With continuous fiber, we can get the strength of aluminum but the lightweight of plastic, as well as non-marring features, so when we lay it up against the part, we're not going to scratch it. And it's just going to withstand and be much more durable than plastic tooling with other FDM-style 3D printing. The application that we'll be spotlighting today is located in this bracket onto the 6-inch aluminum tubing. Now this bracket requires 2 socket head cap screws, which are a 1/4-20 thread. So we're going to need a tool that drills the pilot hole and then taps it at 1/4-20. So the way the tool works is quite simple. We take the tool and we locate it onto the tubing. Then we're going to take a clamp and make sure that that stays locked in. After that, we're going to take our first bushing spoon and insert it into this liner bushing and drill our pilot hole at 0.210-inch diameter. After we remove that, we'll take the second bushing spoon, which has a 1/4-inch ID, and we'll use this as our tap guide when we go in to tap it with 1/4-20. After that, we'll move on to the second hole, and then our operation is complete, and we can locate this bracket precisely onto the tubing. Now we are going to procure the tools for this operation. We will begin by printing the drill plate. Before we are able to print this tool, we need to prepare it in our slicing software called Eiger. We can take a CAD model in STL format, determine the orientation and material selection, then view the internal tool paths and selectively reinforce layers with continuous carbon fiber. Then we can select a printer and seamlessly start the print. After I receive a notification that my print is finished, I can walk over to the printer and easily remove it off of the print bed. Then we need to do some light post-processing steps to prepare the tool to be used on the shop floor. First, we are going to remove the tearaway supports, which can easily be done with a set of hand pliers. Then we are going to use a contrast filler to make the text more distinct from the part for tool number identification and operating instructions. And finally, we will heat press in serrated drill bushings into the tool using a soldering iron. While the drill plate is printed, our procurement department gave us a heads up that the renewable drill bushing is made to order and has a 3-week lead time. Instead, we are going to utilize the Markforged Metal X 3D printer and print the bushing in D2 tool steel. This is only a 2-hour print, so we can get it into the debinding station overnight and then into a sinter tube furnace the next day. After the bushing is sintered, we will do a quick touch-up and open up the ID to a tighter tolerance. This 3-day lead time is much more attractive than waiting 3 weeks from the supplier. Once we have all the details for the tool, we can assemble it together and do a tool tryout on the shop floor.